interaction. Karen Myers is the director of the Scientific Research Institute's International AI Center, a renowned institute that was the birthplace of the technology behind the iPhone Siri. She will next explore how we can enable more effective man-machine collaboration.
Hi everyone. My talk today is on the subject of humans collaborating with AI systems. Now that AI has become increasingly a part of our commercial and social fabric, the question of how we can and should be interacting with such systems is becoming increasingly more important. I'll be looking at this question from a technological perspective and giving some examples of work from my lab at SRI. But there are many interesting sociological and governance issues that are also quite important and timely. Many of you may have seen this report that came out a couple of years ago from Mckinsey on the impact that AI will have on jobs. That really scared a lot of people because there was a prospect of many jobs being eliminated by the automation that AI would enable. I think a more important observation to take away from that report, though, is that really the important thing is that many jobs are going to be facilitated by AI technologies, not fully eliminated by those technologies. So that raises the specter then of us being prepared to figure out how are we going to support humans in effectively interacting with AI systems. On this slide, I've got some examples, some of my favorites of successes or interesting stories about how humans are effectively collaborating with AI already. I'll start with the one on the bottom right. So customer service, as it turns out, is one of the biggest applications of AI technologies right now in the commercial world. How AI is typically being used is sort of in a triage modality. So consumers call in, the technology is listening to what the consumers are saying, and then figuring out what the important problem is and who can best help the consumer address their problem. So really with this kind of triage model, what we're doing here is using AI technology to help make the overall customer service experience smoother and more efficient, not really eliminating the customer service providers directly. Another example, one that's very timely, is related to the use of AI for drug design. Right now, there are a lot of efforts going on that are really trying to look at how we can quickly find various kinds of molecules that might be effective in addressing the coronavirus. And typically the way that these are being pursued is really looking at a combination of combining human expertise with the power of deep learning, trolling through large amounts of data to figure out good candidate molecules, but really being guided by the expertise of the human virologists and chemists. Another example I really like to cite is related to computer chess. There's a great TED talk that Gary Kasparov did a couple of years ago where he talks about this epiphany moment that he had after he was defeated as world chess champion by an AI chess playing program. And the epiphany for him was really to think much more deeply then about how humans and AI systems could work more effectively together. And interestingly, the state of the art right now in chess is that the best performances right now are being achieved by humans that are working with AI programs rather than humans individually or AI programs on their own. So how do we achieve this effective human AI collaboration? I like to talk about 5 different dimensions. Competency at the bottom is clearly very important. The idea that the AI technology is good at what it does, and we've got lots of people in the research community working on that issue. Today, I'd like to focus on 4 other dimensions: transparency, directability, communication, and personalization. Let's start with transparency. By transparency, I really mean the ability of the system to communicate to a human how it's operating. I like to talk about 3 different dimensions of transparency. Let me start with inform. By inform, I mean helping understand the state and the behavior of what the AI is doing. So this is being able to answer questions like what, who, where, how, when, why, that sort of thing. And I've got little examples on this slide related to an application we've been investigating in terms of controlling teams of UAVs to do something like a search and rescue mission. The second dimension is reconcile, and this is really motivated by the findings that people get concerned about using technology if it behaves in ways that are surprising to them. So our notion of reconcile then is helping users understand expectation violations. So to that end, we've been developing what we call proactive explanation capabilities, where the AI technology can understand situations where maybe what it is doing could be surprising to a user, and then proactively notifying them of what they're going to do and why they're doing this behavior that perhaps seems unintuitive to the user. So a very simple example of that might be something like if you had a self-driving car, Normally it takes a particular route to get you to work, and one day it's taking you in a different route. Notifying the user up front that it's going to take this different route and why it's about to do that. The third dimension of transparency I'd like to talk about is priming. So we're really interested in collaborations between humans and AI technologies. And oftentimes there are going to be situations where the AI system is not going to be able to do something as well as the human. So what we'd like to be able to do then is have that system reach out to the human and ask the human to help it solve a problem that it knows it cannot do well. Priming then is about presenting the human with the right information so that they can present an answer to the AI system that can help it proceed with the task. I'm going to move on now and talk about directability, by which I mean the ability for humans to come in and shape and sort of control what the underlying AI technologies are doing. And here as an example, I'm going to talk about a specific technology called Deep Adaptive Semantic Logic, or DASL, that we're developing in my lab at SRI. And the idea behind DASL is what we're trying to do is bring together the power of human expertise with the power of deep learning. And we do that through a hybrid framework in which human expertise can be captured in terms of rules in a logical-like representation. Those are then compiled then into a deep learning structure. And at the bottom of that structure then we have various kinds of deep learning mechanisms then that can pull information out of data and relate it up to the expertise that the humans have. And with this kind of hybrid system, we're sort of getting the best of both worlds in that we are enabling the expertise from the humans encoded in the rules to influence the learning that's done at the lower levels, but also having the learning influence the weights that we might associate with various rules that have put in the system. So we might understand then that maybe certain rules that we thought or guidelines that we thought were accurate are perhaps not necessarily reflected in the data that we have. So I've talked about explanation and directability, which are really about communicating information back and forth between the human and the AI system. Then the question arises is how we support that communicability. I'm going to talk in this slide a little bit about progress that's being made in the field in this area. So I think a real watershed moment for all of us was really the introduction of Siri, which really shifted us from thinking about interacting with technologies through typing to doing it through the modality of voice. Siri was really a first generation technology though, from the perspective that it was focused on sort of one-offs, commands, individual things. So you could send an email or order a pizza, but there wasn't really a sort of ongoing interaction with the user. In our lab now, we're focused on sort of more extended kinds of interactions with the humans, really dialogues, if you will, and dialogues that are focused on accomplishing higher order tasks. So on the slide here, I have an example of an application that we co-developed with BBVA, a big Spanish bank, that was focused on building a dialogue system to help consumers navigate complex online banking transactions. And this is actually technology that BBVA has now deployed throughout their network. As another example of sort of moving that technology forward, I like to talk about beyond words. So it turns out beyond the linguistic elements that you get in speech, there are lots of really valuable kinds of non-linguistic elements that you can take advantage of as well. So these are things like volume or pitch or the speed at which people are speaking. And from these, you can actually come up with good models of things like sentiment or emotional state or to some extent even mental health in certain kinds of situations. So there's work going on at SRI where we're trying to harvest these non-linguistic elements to help us better model the state of the speaker with whom we're interacting and use that information to build more effective dialogues with the human. The last dimension I want to talk about briefly is the idea of personalization. Again, there's lots of evidence from the psychological literature that if you build technologies that are more customized to an individual, people can work more effectively with those technologies. And the reason of that is can vary from having different expertise levels. So going from people who are novice to experts, to also just people feel more comfortable if technologies work in the way that they want them to work. So as a simple example of that, we built a customized meeting scheduler that could learn from observing humans on how to do things like when to schedule meetings, who was important for meetings, or even how to remind people about when meetings were coming up. In closing then, I'd like to just emphasize 3 takeaways from my talk today. The first and most important point, I think, is that humans working with AI are going to produce better results than either working alone in many kinds of situations. And as a result of that, the second takeaway is that it's going to be very important to design AI technologies to specifically support these kinds of collaborations. And finally, the third point, I really think the future is going to be these technologies like the Dazzle capability we're developing that effectively combine symbolic and neural models. Thanks very much.